So first to begin, what is PACVS? That is post-acute COVID vaccination syndrome. And this is a syndrome which presents similarly to long COVID. It occurs after vaccination. It is a contested illness because, yes, there's no real diagnostic criteria or a billing code in order to diagnose it. So officially, it doesn't exist. Um, However, there is a growing literature to characterize PACVS and describe its mechanism. So we've discussed lipid metabolism, capnia, as well as lactate. So starting with the lactate threshold, basically what you see with individuals with long COVID is they have a much reduced lactate threshold. So their muscles start this burning sensation at a much lower level of exertion. So this makes it very difficult for people to do activities of daily living. Um, you know, there's often post-exertional malaise, so people need a lot of rest after comparatively light exertion compared to their prior fitness state, and yeah, they're not able to exert as hard. So interventions to address this, there are some acid buffering strategies such as sodium bicarbonate or baking soda, which the principle is, it's the burn of the acid that causes the pain. So if we add a base or a buffer to that, we can decrease the effect of the acidity. And that seems to have an effect. There have been reductions in lactate threshold by some 20 to 30%. I don't have the exact figure before me, but yeah, relatively significant. So that's one approach, and there's also specific compounds such as the cordycepin in cordyceps mushrooms. It's been proposed to increase VO2 max, which is generally proportional to lactate threshold. Okay, so that's it for lactate threshold, and we also get into capnia. And so essentially it is your end tidal CO2 concentration, so at the end of a breath, that determines so my apologies. It is the CO2 concentration in your blood which provides the signal for oxygen to enter. So it's not about oxygen is good, CO2 is bad. It's that you want high CO2 in your tissues in order to bring oxygen in. So it does sound sort of paradoxical in our understanding of, CO2 is a waste gas. It's oxygen that our cells need, but really it's both, and CO2 is the signal for oxygen to enter. So there are techniques such as with free divers, they build up a tolerance to higher levels of CO2. And you do see in people with long COVID, they have this reduction in their CO2 tolerance. So this impacts, this impacts their oxygen delivery, which in turn can impact their metabolism. So basically, structured training like potato breathing or something similar to free dive training, such as just breath holds for progressively longer periods of time. Free diving, just dial it back a little bit for your level. That can be an approach. And yeah, that's it for capnic state. and now finally beta-oxidation. So there's some specific compounds. Basically, beta-oxidation, it's very intimately tied with aerobic or anaerobic respiration. There is not an anaerobic metabolic pathway for lipids, at least not an efficient one. And so basically at decreased oxygen levels, you do not burn lipids. And you see this at lower levels of exertion, your body tends to burn fat, and at higher levels of exertion, it tends to switch to carbohydrates. And this is the basis for fat adaptation in, say, endurance athletes. So for fixing altered beta oxidation, we basically do the same process of fat adaptation, but it's to bring us to a baseline. It's not for ultra marathons or anything like that. Maybe in the future, but yeah, basically, there are structured training plans which can help this, by consuming a more high-fat diet and also training endurance levels. This is difficult because you are getting, at your physiological limits, and, the warnings about post-exertional malaise, they apply here because exercise can be a negative in someone with PACS or PACVS. There are some compounds as well, as mentioned before, cordyceps, metformin, bicolin, and a possible role for CoQ10, as it plays a key role in mitochondrial function. Additionally, people have looked to acetyl L-carnitine because carnitine helps to deliver fat to the cell, and it may improve the efficiency of this process. So these are some of the therapeutic approaches to PACVS. I will link the recent publication below. Anyways, thank you for your attention, and be well.